Mischa, can I get you to read the antitrust compliance statement?
Sure. The Advanced Water Heating Initiative is a member-supported collaborative of professionals from across the U.S. This diverse membership includes numerous competitors, and care must be taken to scrupulously abide by federal and state antitrust laws. Members should remember that antitrust compliance is important at all times. At this and other AWHI meetings, participants should not discuss competitive pricing, profitability, allocating markets or customers, or promotion of a particular product or accessory.
Awesome. Thanks so much. All right, so quick call agenda today. We'll go through some AWHI updates and talk about upcoming events, including Heat Pump Water Heater Day in late October. Then Misha and I will talk about HVAC and water heating load shifting results from a really cool pilot in Austin that we had the fun of leading data analysis on. We'll have some Q&A and open discussion, and then wrap up and talk about what our next session will entail. And of course, if anyone has ideas or wants to present themselves on future sessions, they're more than welcome. If anyone has not been on this call before, feel free to come on camera and introduce yourself and where you work. Seeing mostly familiar faces, though. All right, I think it's all a returning crowd today. Welcome back. Few AWHI announcements. There are a couple cool upcoming webinars, including one on microgrids through Electrify Now. So those are always great. Highly encourage you to come to that. And then also one on high efficiency windows that I'm getting to lead on August 26th. The actual registration link is not up yet, so I will keep I'll forward that over once it's ready. But if you're interested in high efficiency windows and want to mark your calendar, I encourage you to do so. We'll have a bunch of cool manufacturers on and some national lab researchers who are doing some really amazing innovations in a subject. Jeff?
Yeah, I just wanted to point out Nia had done a lot of work with this. Have you connected with them on there? Because they were actively involved in this for a good 5-6 years. They revolutionized vinyl windows in
I
the
think I
90s.
connected with someone who was formerly at NIA, and he recommended a couple of manufacturers to reach out to.
Okay, I realize this is a shift from AWHI normal charter, but I just wanted to point that out.
No, that's really helpful. And yeah, Jeff, if you wouldn't mind emailing me the name of that person just to make sure it was the same one I spoke with before, that would be excellent.
Will do.
Sweet. Yeah, but definitely encourage you to check those out. A couple of new resources. My colleague Vidisha at NBI did a great history of heat pump water heaters fact sheet and blog post. Joe Wachunas, who I'm sure you all know, has started a really cool podcast called Heat Pumps and Cardigans, where it's a fun opportunity for Joe to speak with a variety of heat pump water heater manufacturers. The first and most recent episode is focused on GE's new GeoSpring, which we talked a little bit about during last session, but I think that'll be awesome for load shifting because it can go up to 160 degrees, which is hotter than any other single family unitary unit at the moment. So that'll be great for load shifting. Of course, it's CTA 2045 enabled, and it can come in a variety of different configurations from 40 to 80 gallons. So I'm hoping someone will get a load shifting study done on the new GeoSpring at some point, but definitely check out that article and video cast from Joe. And then, of course, we have Heat Pump Water Heater Day. It's coming up pretty quickly already on Thursday, October 23rd, so just a couple of months. Jigger Shaw is excitingly announced as our keynote speaker during that day. And of course, Heat Pump Water Heater Day is going to be a full slate of events. So we have a variety of subjects, including a webinar and roundtable on heat pump water heater load shifting. So definitely make that as well. And then just a few of our sponsors here at the bottom. And we have a fun theme for this year called Go Go Heat Pump Water Heaters, based on a kind of retro comic. So that's our theme for this year. We kind of try and keep it fun every year with a different theme. And just a couple updates on the world of field studies that NBI is doing. We installed a couple, we installed monitoring equipment at a few different grocery stores and other small commercial buildings throughout the Northwest and California. So a lot of cool stuff going on there. And if you want updates, definitely attend our commercial working group meeting. And same thing for an IntelliHot installation in Chicago. Previously, we had 2 gas boilers here, and a retrofit happened to where it's now 4 IntelliHot IE1s with a tankless gas backup. So those are the 2 most recent developments in our load shifting in our field studies. And if folks have their own field studies they want to have highlighted, definitely let me know and I can touch base on them in our next working group. With that, Mischa, do you want to go ahead and share slides?
Sure.
And we'll get into our Texas load shifting pilot.
Yeah, let me get my screen share going here. And I'll just do a quick intro. My name is Mischa Egolf, for those who don't know me. I work with NOAA, and we've been working together on this field study, this pilot in Texas. It is an ongoing project. It is funded by the Department of Energy, and we are currently uncertain about its future, but we do have some preliminary results, so we're going to share those with you today. So it should be hopefully showing on my screen now. So
looks perfect.
All right. So this pilot program's goal was to target multifamily buildings and increase demand response and resiliency. They were piloting a dual incentive kind of approach and a dedicated device network that would allow them to control both the air conditioning units and electric resistance water heaters in the apartments. The incentive design was for each participating tenant. They got a $50 one-time, I guess, like enrollment credit, and then somewhere between $25 to $35 annual bill credit. I think there was some, it depends on their income. And then for the property, they get free installation of the technology, the load shifting technology. And then for every device that's enrolled at the property, they get $5 per year. So, for properties that have 200 plus units, if everyone is enrolled for both their air conditioners and their water heaters and, fully opted in, that could be, a couple $1,000s a year. So not insignificant. And, this utility has definitely some goals related to demand flexibility, and Texas certainly has very high demand. This chart that NOAA made shows the annual grid peak, and you can see that it's continuing to just go up and up, exceeding 80 gigawatts. So definitely important to look at this technology. So just to give you a little more information about the type of properties that were included, there were 2 properties right now. If it continues, there may be a 3rd property added. The first property was built in the 80s, and it's got about 200 units. The second property was newer, built in 2024, a little over 200 units as well. Both are kind of multi-building, 3-floor garden style properties, with lots of trees and yards and everything in between the different buildings. But they all have 2 to 3 ton HVAC equipment with electric resistance heating and 30 or 40 gallon electric resistance water heater. So here's a picture of one of the typical water heaters. So for this study, it included a few different technology pieces. There were water heater controllers. So you can see an example here of the kind of analog timer that existed before the replacement. And then what was installed for this study was Armada power controllers. And They also installed new thermostats. And so they had old radio frequency thermostats that then very limited in terms of their functionality. But as part of this program, new DR enrolled Ecobee light thermostats were installed. And to be able to kind of control all of these things together, the goal was to have like one singular communication network that everything was kind of like connected through. And so what ended up working for them was a Wi-Fi network from the cellular Cat-M network that is through the Armada controller. So basically the Armada controller for the water heaters was also acting as like the Wi-Fi network for everything. And we also installed, or the utility also installed M&V equipment in about 5% of the installed units, and we used eGauge for that. So in terms of the actual events, for water heaters, they ran daily events for a lot of the months, and they did in the summer, they did both a morning, well, in both seasons, they did both a morning and evening event. And in the summer, they did from 1 to 5 a.m. and 3 to 7 p.m. And then in winter, 6 to 9 a.m. and 6 to 9 p.m. And, you know, I'm sure some of you are wondering why 1 to 5 a.m. Could not tell you. That was totally the utility design. So that's a good question that we can kind of take back to them if people are wondering that. But yeah, that's the periods that they basically just, yeah, switched the water heaters off. And there were, through the Armada platform, you can see kind of highlighted here in this screenshot, there's a lot of configurable settings. So typically, they set a preheat period of 30 minutes before the the shed event started. They also, you can limit your, or kind of dictate the kilowatt allowance during that preheating period. I think it's like 1% of the nameplate that you can dictate. You can also dictate a curtailment power limit, so your allowance during the event. And then also your rebound period duration. So when it's kind of trying to recover, typically that was set at 2 hours, and then also can set the kind of allowance for how much power you're going to let them draw during that period. So very customizable. With the thermostats, these events ran kind of on like select days, kind of like the most critical peak days in the summer, June to September. It included a 30-minute pre-cooling period where the temperature was decreased by 2 degrees Fahrenheit, and then a 2-hour curtailment from either 3:30 to 5:30 or 4 to 6. The default setting in terms of the shift during that period was shifting up 4 degrees Fahrenheit, but kind of one of our findings is if folks have set up a profile via Ecobee, that could impact the amount of shift. So we'll see this in the results, but even though there was kind of a standard goal in terms of the logic of the events, that wasn't actually always what happened, which definitely made understanding the results a little bit challenging. So there were, however, 22 events that were called in the 2024 season. So, you know, the technology did work and was able to be deployed in that way. So I'll pass it to you, Noah, talk about results.
Perfect. All right, I'll take control here so I can shift. But yeah, thanks a ton, Mischa, and really helpful context there too, because as you could see, there were different controls for the water heaters versus the air conditioning, and I think it's yeah, a bit of a foreshadowing there that the air conditioning controls were not super aggressive, and I think that's going to be shown in the results. And I'm getting some weird gray blocks here. So you know what? I'm actually, Mischa, will you take control back and I'll just request you to move slides? Awesome. Yeah, it was just Teams was doing something funky there. So just for some context setting, before talking about load shifting results, we just wanted to show what the seasonal water heating energy use was, and this is going to be broken down by the apartment level. So if you look at the bottom there, A001 through B191, those are just the apartment IDs. So you can see little box plots here showing the range of energy use, specifically for these electric resistance water heaters between apartments and by summer versus non-summer. So this wasn't quite a full year, so we don't capture all of the different seasonal shifts there, but especially since it's just Texas anyway, and there's really just a hot versus less hot season, summer versus not quite as hot time of year is really what you want to pay attention to here. And just to, kind of establish our baseline prior to talking about load shifting, you can see that the average during the summer was somewhere around 2 kilowatt hours per day per apartment, and it was closer to 4 for the non-summer use. So as one might expect, based on previous literature, more energy is used during the colder times of year, even if it's only relative because it's Texas. But folks are often going to take longer showers and whatnot, perhaps use hotter water for various other applications like dishwashing during the winter. So that kind of all stands to be expected. And again, this is a context setting slide, so we know just how much of this load we're shifting when we actually apply DR. So next slide.
I might just jump in really quick to mention that these apartment IDs are the ones that have the e-gauge meters. So the results showing here is kind of that subset of those representative units that got the M&V. So just wanted to mention that.
Yeah, so it's 11 per apartment, right, Mischa?
Per building, yeah.
Per, yes, awesome.
Or property.
Yes, totally. So as Mischa said, these DR signals were being sent to all the units that had that applicable technology and were opted in, but we only metered a subset because it's expensive, right? But hopefully it was kind of showing enough of a sample to get close to what the actual population baseline looked like. But yeah, so water heating, we wanted to take a look generally at what event versus baseline looked like for September, October, November, and December when the load shifting events occurred. And you can see besides October here, there was quite a noticeable impact on average hourly energy use. So massive curtailment in 3 out of those 4 months. We're not entirely sure what happened in October, if the conformance to the signals was not being properly used. Oh, and a question from Stephanie here. It looks like, is this only during event hours or the full day? So this is if you basically take an average of all the hours for events during this same period versus all the hours for baseline. So baseline versus events here, averaging a single hour. So basically how you want to read this chart is, say for September, an hour that was not being load shifted, you would likely use about 160 watt hours. And then during an event hour in September, you'd likely only use about 30 watt hours. So yeah, that's the interpretation there. Again, not totally sure what happened in October, but you can see the extreme effectiveness of the controls in November, where whenever an event was called, curtailment essentially reached 0 for those 2 hours in which the water heater was being told to turn off. So unlike a lot of the CTA 2045 controls and signals that we're usually talking about in this group, we don't quite have that level of kind of full control that we could tell our water heater to throttle down or do a shed. This is more of a, turn off until it reaches a certain threshold, right? So slightly different here, but still pretty successful results. Next slide. Yeah, so the whole apartment meter data is going to kind of validate those same findings. So Mischa, do you want to talk a bit about how the whole apartment meter data worked versus the individual power metering for the units?
Sure, yeah. So this was just another data source that we used to kind of validate our findings. So we had the e-gauge M&V, meters. We had the actual what the tenant unit meter saw, kind of for the whole apartment. And then we also have data from Armada. So we had these kind of 3 data sources that we're using to corroborate all this information. And basically the takeaway here is just showing that in October, there's not really much shed in terms of the hourly kWh for water heater, or I'm sorry, during the water heater event periods. But in November and December, you are seeing, basically what the entire meter, the entire apartment use is going down because of the water heater use going down. And it's about the same in terms of the magnitude. So just trying to show kind of in terms of study design and stuff like that, that there is a little bit of a check and balance here in the data that we're seeing.
Awesome. Thanks so much. And next slide here. And then this is a similar view here, just kind of displayed slightly differently, again, for baseline versus event over the course of a whole day. And this is for your entire baseline for all the time we were measuring data for baseline versus an event. So this is an aggregate really of the whole thing here. And so you can see, in general that you're going to have a pretty sharp decline in the early hours of the day per the study design, a pretty large spike immediately following as you have that rebound effect, and that'll be echoed in the morning and the afternoon. So again, just showing that generally speaking, water heating load shifting was quite successful. Next slide. So it's a little bit of a different story for thermostat design. I think it goes to show that air conditioning load shifting is a bit trickier. Again, to context set here before we dive into results, though, we show the opposite pattern as one might expect from water heating, where in the summer, of course, you're going to be using a lot more HVAC. This is specifically looking at condenser use. So you can see some pretty wild spikes here from apartment to apartment and from day to day. So each square here, be it orange or blue, is going to represent 1 day of energy use. And if you want to take a look, for example, at A061 during both the non-summer and summer months, you can see a crazy variability there, right? Between kind of clustered around 5 to 10 kilowatt hours, and then some crazy spikes all the way up to like 30 kilowatt hours in a day. And we did already filter for outliers here because you can see for other apartments too, such as B033 and B045, there were plenty of days per year during the summer where there were more than 20 kilowatt hours used. So pretty darn energy intense air conditioning units here. So not the most efficient, so that made them all the more important to load shift. So next slide. And again, just kind of corroborating like Mischa said, using whole apartment meter data and, showing some similar results here. Next slide. So we wanted to zoom out and take a look at weekly load shifting results. So if you look at those at gray bars, that's going to be your baseline. Orange is your curtailment periods, and then blue is pre-cooling. So it's a little bit hard to see here if your screen's small, but I want to more point you towards the overall trend anyway. These are 2 different weeks in which events were called. Over on the left there for property A and B, there were 3 events called, and the chart on the right, there was just 1 event called during the week. But the thing that should kind of literally spike out to you is the orange curtailment periods. They look pretty darn high. It doesn't look like there was a big drop. And that was kind of concerning to us, indicating that perhaps load shifting was not working. But this was just at a glance, and it was not accounting for what are called cooling degree days or cooling degree hours, basically meaning we did not account for temperature during this in this visualization. So our early thesis was that perhaps since these load shifting events are being called on the days where the temperature is the highest, basically the highest number of cooling degree hours, then perhaps that's skewing our results a little bit. So we wanted to dive even a bit deeper since this initial visual and exploration was not showing much in the way of curtailment. Next slide. And even with filtering for cooling degree hours, we did a little custom calculation in Tableau on the right there, where we only included hours that were 28 degrees to 41 degrees above the cooling degree baseline, which is 65 degrees. So all that means is basically between 93 and 104, or sorry, 106 degrees. So basically only filtering for baseline days that were similar to when the curtailment and the pre-cooling events were being called, basically just during hot days, right? So we wanted to make sure we weren't looking at baseline hours where it was a bit colder outside, usually during the evening and nighttime. And as you can see here as well, curtailment was not noticeably smaller in terms of average kWh per hour than the baseline was. And you'd think pre-cooling would be much higher. We see a bit of a trend happening here in September where pre-cooling is higher, curtailment is a bit lower than baseline. So that's kind of what you'd expect, but still, not a huge visual jump there. Next slide. And to zoom in even closer here, we're receiving 15-minute level energy data, and we thought that might unlock some patterns that were more easy to distinguish just by looking at them without running a regression or something. And I'm going to show in the next 4 slides just an example from each month during summer where there were load shifting events sent. And I think this 15-minute level is going to really illustrate that these events were working to some extent. They just weren't necessarily aggressive enough. And that will kind of make sense given that there were only 2 degrees of pre-cooling that happened and only a 4-degree shift upwards. And it's just hard to do AC load shifting again, because if you're doing more than a few degrees up or down, that really might impact occupant comfort and have people opt out. So it's kind of a fine line to toe. And just looking at our key here, or HVAC event status, you can see blue is pre-cooling, orange is curtailment, red is the hour after the events were called, and then gray is your baseline. And this particular visual exhibits some of the behavior we'd expect, where pre-cooling is somewhat higher, not too noticeably, right? But again, it was only 2 degrees Fahrenheit that were pre-cooled. During our curtailment period, it does start lower and then slowly goes up as the kind of energy take requirement goes up to use some air conditioning. Our post-event hour, there's a bit of a spike at first, and then it drops off once the space is presumably cooled again, and then baseline just resumes normal, somewhat spiky activity. Next slide.
I might also just note, Noah, as I move to the next slide, like the pre-cooling is also only 30 minutes. Like
You're so
it's
right.
2 degrees, but it's only 30 minutes. So just keeping that in mind as well.
Great point. Yeah, Jeff?
Yeah, thanks. Have you thought about the thermal mass, or I should back up. These, I assume, are sheetrock apartments. So there is thermal mass with that sheetrock. Have you calculated how much thermal mass was in each one of those apartments? And 30 minutes of impact on sheetrock is not really enough to heat or cool sheetrock. So it might be another facet to look at, to think about what is the mass within each one of those, because that is a storage element.
Jeff, that's an excellent point. And Mischa and I are hoping to continue this research depending on whether it's approved or not. But yeah, that was not factored in. I kind of came in, and so did Mischa, near the kind of analysis point and less of the study design. We weren't, unfortunately, the ones who got to determine these cooling and preheating parameters. But that is an excellent point, Jeff, and totally agree there. We thought it was too conservative as well. Mischa, anything to add there?
No, yeah, I think it's totally worth thinking about the mass and looking at the construction for those 2 buildings.
I'd suggest connecting with Christopher Diamond. He's done some calculations on what the thermal mass is of say a 400 or 600 square foot apartment, and what its capabilities are, and what the decay factor is of releasing that energy over time.
And would you have to do some sort of blower door test, Jeff, to determine like average air cycles and heat loss?
Well, that's a component of it, but I think as long as they're not too drafty or they're not leaving windows open, there should be, if you've got enough time that sheetrock will absorb heat or cold and will release it over time. But 30 minutes is not sufficient. You need to, and it'd be better actually to drop it down a degree for 2 or 3 hours rather than 2 degrees for 30 minutes.
Totally agree. Yeah, and I was talking to some folks about a different study that happened in Hawaii actually, where they were advised just against pre-cooling in general because it was such a drafty place. So I'd definitely be curious to see in this case if there's enough baseline insulation and if the windows aren't too crappy and single pane to to make this work. But really great ideas there. Tristan, do you have a hand up too?
Yeah, just a quickie. Seems to confirm what we always thought.
What was that? I think you're cutting out a wee bit.
Water heating, where keep it. Can you hear me now?
Yep, I can.
Hello? All right.
I can hear you.
Okay, so it just confirms that real shiftable loads provide more value with less occupant concern, such as water, heating, obviously, and then real shiftable HVAC like Harvest Thermal and others.
Yes.
So glad you guys did this. And it just shows that we need to continue to shift to real shiftable loads. But thank you for what you're doing. It's great.
Yeah, thank you. I appreciate it. And yeah, no, I totally agree with you that it's always tricky for HVAC. I mean, I know we had that great PNL research presentation a few months back, right, on the CTA HVAC shifting in Alaska, and I think it showed some similar challenges, right? So but anyway here, yeah, so just again, similar patterns through other weeks that we were seeing. I did want to show this particular week because you do see more of a noticeable rebound effect. Perhaps the curtailment lasted a bit longer. You can see that it's really quite flat for the first 15-minute periods there in orange, but then you do see that it was unable to continue curtailing, and then a noticeable rebound effect for the first 15 minutes. So next slide. Just taking a look at August here, I'm not sure if the control logic was changed here. Perhaps it was, because we do see, more of a noticeable shed throughout most of that 2-hour window, and then quite a huge spike right around 6 p.m. Again, it's hard to necessarily say if that's because folks are coming home from work or it's because the shed was actually able to last longer, but certainly interesting results nevertheless. And then we see a slow and gradual decrease around 7 p.m. into nighttime when folks are, likely going to bed or turning off their AC because it's no longer so hot outside. Next slide. And then September, this one was, I think, the most interesting of all, where you had the most noticeable post-hour spike. And I think that's why we really wanted to go down to that 15-minute level here, is to illustrate certain trends like this one where, again, curtailment is slowly creeping up in energy use. And then in that post-hour, you do see a huge rebound effect. And if we were to get more, air conditioning units, shiftable resources on the grid, that's going to be something that program managers and utilities have to keep track of. I know we've had researchers on these calls before talking about rebound effects, such as Dr. Bass and Peter Grant, and the ability to kind of slowly let different assets off their curtailment and rebound more slowly. So that's just a good consideration. I know in this study we do have some controls around post-hour energy use and rebound use, like Mischa was talking about, but I'm not sure exactly how effective that was, given that we do consistently see spikes after that curtailment period's over. Jeff?
Yeah, good stuff here. And I think it's worth noting, you got to remember a couple things with the building stock in Texas.
Yep.
One, they're not great. And two,
Yeah.
August and September are generally their hotter months, and there is a lower sun angle that also may be impacting the west-facing windows, which would force this up, even if it even if the temperature was right, the sun may be hitting a thermostat. So, I mean, there's all kinds of variables there. Whereas if you look at, say, June, July, those buildings have not heated up over the duration, and or there's a dampening effect. So I'd look at the diurnal cycles as well as the seasonal cycles of temperatures.
Super interesting. Yeah, Mischa, if we get a continuation here, it'd be fascinating to look at the east versus west facing and potential solar heat gain.
Yeah, for sure.
Yeah, really fascinating points,
Great
Jeff.
add.
Thanks a ton. Next slide here. Yeah, so Mischa, do you want to get into kind of implications and if we were to have this pilot elsewhere and sort of kind of bigger picture ramifications?
Sure, yeah. So I guess this is just a little bit more context and kind of thinking about where you might want to replicate this if you wanted to replicate it. Texas has a lot of multifamily units. So that works in its favor in terms of if you wanted to pilot this kind of multifamily, everything connected to the same network kind of approach. So that's something to think about. Also, of course, we all are familiar with kind of the map of where the existing electric resistance water heaters are. That obviously worked in favor because they're already there and easy to do this kind of on-off switch. And, I think that this is also kind of going back to the beginning, talking about ERCOT is especially kind of a unique setup. They do have the kind of 4CP program, which means, utilities have to are allocated like a certain amount that they have to pay for the load that's on the entire system. And so from the utility perspective, they're very interested in shifting this load and like lowering their cost burden. So thinking about, that as well.
Yeah, it's basically like a demand charge for utilities, which is a super interesting kind of market component.
Yeah, totally. But yes, there were a lot of challenges in addition to some of the just basic design stuff we talked about. It was really difficult to engage property owners to get enrolled. Getting those two buildings or properties enrolled took a long time, and we had to request kind of like an extension, a no-cost extension, because just the legal like paperwork aspect, when you've got a utility trying to contract with a building, it's just messy. There is also some dead zones. And again, I think that goes kind of to Jeff's point about the building construction. So that's something to be aware of. The thermostats, even though they do have, this great, shifting capability, there's this level of complexity that made it challenging, I think, both for the utility to configure for the events and also because the customers could set up a profile and set up their own kind of custom schedules. Those schedules kind of interfered with the utility signals at times was what they were finding. And so that was definitely a challenge. As you would expect, tenant turnover is certainly a challenge. You have a new tenant coming in and now you have to try to educate them and make sure that they're, okay, continuing with the enrollment. Building staff, if you've worked with them to install the whole connection system and everything, and then the building staff turns over, now you've got to do that education again. I think in general, it's difficult for the utility to just manage and understand the data. So that was kind of our role here, but it was a relatively high overhead cost for the amount of load shed, as you saw, especially for the thermostats. It wasn't very high. And so just trying to think about what would make it worth it for them in the longer run. So those were definitely some challenges, not to like end on a negative note, but it is a really interesting study. And I think the key takeaway is like water heating worked beautifully. Thermostats are a little bit harder. And this concept of like a full network, it just comes with some challenges. So I think I'll leave it at that unless you've got anything to add, Noah.
Yeah, I think we can wrap it there, but there are a few questions in the chat. Thanks a ton, Mischa. So I'll direct a few at you here, if that's cool.
Yeah.
So Bruce asked, is the effectiveness of pre-cooling separated out for each building?
Oh, kind of like in those charts that showed because I think the charts that you showed now were kind of the aggregate of both properties, right?
Yeah, some were accurate. I think some did show apartment A versus apartment B, but we can definitely, I think they were separated some, but do you know if the research team had any considerations for differing the schedules between buildings, or did they use the same exact load shifting schedule for each one?
Good question. Yeah, so for the most part, they deployed the same logic to both properties. I don't think that they had any specific events where they were like, let's try it at this building, but not this, or this property, but not this property. So that would have been a great kind of add to the study design. But I think in most cases, it was just like they're both getting the signal or neither of them are getting the signal.
Awesome. And then question from Kevin here. Customers were given incentives to opt into the program. Are they allowed to opt out at any time?
Yep. Yeah. So I think with the water heaters, it's a little bit more like they would have to manually flip the switch, so to speak. There's not like any sort of app or anything that the customers would use for that. But for the thermostats, yeah, since they're the smart thermostats and they have an app and everything, they could opt out of specific events, or they could opt out, entirely by calling the utility and just saying, I don't want to be involved at all anymore. And it would be great to know that information, but that is not information that we had for this presentation today that we could overlay, unfortunately.
Yeah. And then Eric was asking about any building improvements from the 1983 building. Do we think it was mostly just as is from construction? Do we have any details on that building itself?
That's a great question. I don't know that we have that information. It's a good thing to ask them.
Totally, yeah. Like if there's any new installation added since then or anything, but it is Texas after all, so who knows? And then can you restate the HVAC details? Were they P-tax? You said they had electric heating, right?
They're just split systems. So and we did actually for our metering have kind of like the fan unit and the condensing unit, as Noah mentioned. And so the results we were showing today were just focused on the condensing unit since it's much more energy than the fan unit.
Yep.
But yeah, kind of your classic like exterior, you got your exterior unit and your interior. Jeff?
Yeah, so when you say split system, you're talking about a single or two-stage air conditioning system, not a mini split system with a variable speed drive or anything.
Correct. Yeah, not a
Okay.
mini split. Yep.
Now, for some reason, my chat is not working, so that's why I keep interrupting you. I'm sorry.
Oh, no problem at all. Always great to hear from you. Cool. Any other questions, folks? Eric?
Yeah, were there any Wi-Fi issues? We keep hearing about the the precariousness of Wi-Fi connections, or did the Armada system kind of overcome those issues with the Wi-Fi or with the cellular signal to the Wi-Fi routers?
Yeah, so there were still some like dead zone issues. And I don't know that I think the utility folks went out there and tried to kind of troubleshoot, and I think it may have to do with like the building construction. But for the most part, it was pretty solid. I think there was pretty high connectivity once they sorted out like the placement of different things. So I think that was an initial challenge, but they were able to, as I recall, upwards of like 90%, connectivity for all of the events.
Awesome. Yeah, good question, Eric. Okay, yeah. Any final thoughts here? Otherwise, I'll wrap things up and talk about next session. Thanks a ton, Misha.
Yeah, thanks for having me. It was fun to talk about.
Absolutely. Yeah, and if folks have any questions, you can definitely feel free to follow up with Mischa or myself. This was recorded, so definitely send that out afterwards. And I actually wanted to note that when Peter Grant was on last time, that YouTube recording got posted a bit late, so I will follow up and send that out at the same time that I send this recording out. Next month, I'm going to get on the calendar in a bit, but it's going to be Friday, September 5th at our usual time. We'll have Madison Johnson from Ecotope on to talk about a cool 2024 load shifting study that Ecotope did in collaboration with a couple of other partners. And then we'll also have Watt Time on, which is exciting because they provide like real-time emissions data for load shifting applications. So if anyone's wanting to deep dive into like GHG reductions, that is that'll be a great session to see. But anyways, we'll wrap up 14 minutes early here today, give folks back a bit of time, and hope you have a lovely weekend. Thanks for being on.
Thank you. Nice job.
Thanks, Noah.